This chapter is about, this is week 4, chapter 8, TCP IP Suite. The TCP IP, before we start talking about TCP IP or OSI, why we need a protocol, why we should follow a standard. There are different reasons. These reasons are, it is better for computer communication because the exchange of information between computers is important for the purpose of cooperative action, for collaboration and cooperative. It is good for computer networks because 2 or more computers interconnected via a communication network, then they can communicate with each other. Okay? In your protocol, the protocol is used for communication between entities in different systems. What is entity? Shabab, can you inform the students if you have WhatsApp group just to come back? I don't want to repeat at the end because I have capstone. If you have WhatsApp or something, just tell them to come back, please. It's okay, you don't have to create WhatsApp. You have his number, just call your friends. So we have entity, they can watch the, I am recording, right? I am recording, but I will take attendance again. Attendance is important. So entity is capable of sending or receiving information. So examples are user application programs, file transfer packages. These are all entities. System is a physically distinct object that contains one or more entity. Examples are computers, they have entities. Terminals, remote sensors, okay? Protocol is a set of rules governing the exchange of data between 2 entities. We have different elements in a protocol. We have the syntax. Syntax includes such things as data format, signal level, is all in the syntax of the protocol, syntax. Then we have semantics. Semantics meaning the control information for coordination and for error handling. This is semantics. So the semantics of a protocol is, this is the meaning of semantics. We have the timing, includes speed, matching, and sequencing. So the protocol have these 3 elements. Any protocol should have these 3 elements. Control. The control of the information. Yeah, the protocol, it's like when you are talking to, like, you know, like when you are, they tell you that there is a protocol for reception. There is a protocol. We are not talking about what's inside the reception. We are talking about how it will start, how it will end, speed. All right? Standardized protocol architecture. Why we need standards? Or what is the advantage of standards? Vendors, they like it because they make their products more marketable. Because we have ISO, they are following the standard of TCP IP, then they can sell it. Customers like standards because they enable products from different vendors to interoperate. They will work. You buy a computer from Dell, you can buy the mouse from HP, no problem. They will work. 2 protocols architectures have served as, these are the most famous ones, TCP IP and OSI. A widely used proprietary scheme is IBM System Networks Architecture. SNA was only for IBM. It's proprietary of IBM. There is no official TCP IP model that everyone agrees on, but still we will ask you in the exam, what are the layers based on the textbook or based on what we study here? We have 5 layers: application, transport, network, data link, and physical. No, we talked about OSI layers, 7. This is TCP IP, 5 layers. TCP IP layers, each layer in the TCP IP suite interact with its immediate adjacent layer. Always they talk to the adjacent layer, on top or down, or with the same layer in the receiver. At the source, the application layer makes use of the services of the transport layer and provides data down to that layer. Okay, a similar relationship exists at the interface between the transport and internet also. So each layer talks to the one next to it. The application layer will not talk directly to that physical layer. It has to go through the layers. TCP layers. One example is the TCP. TCP is the most commonly used protocol at the transport layer. The IP stands for Internet Protocol, is used at the internet layer, layer 3, to provide the routing function across multiple networks. One example of a device that uses IP is the router. The router connects 2 networks, and its primary function is to relay data from one network to another. The router will connect multiple networks. The network access layer provides the attached network with the information needed to reach a router that connects the network to the next network on the route to the destination. That's the network access layer. The physical layer is concerned with specifying the characteristics of the transmission medium and the nature of the signals, the data rate, the related matters. It's very important for WAN links, by the way. Okay. Which layer we did not talk about here? Application layer. Very good. Thank you. PDUs also, they have names according to the layer. In the application, it is called data. In the TCP, in the transport layer, or used by TCP, it's called segment. And segment will add a header. It's called TCP header. The network layer, it is called, or the internet layer, it is the PDU is called packet or IP datagram. And the network layer will also add a header. The network access layer, it is called a frame, and the frame is adding header and trailer. It's important layer for WAN. So this is again the summary. As you can see, we have TCP segment, datagram or packet, and then frame. And then in the physical, what is it? Bits. So TCP and UDP, we have 2 different famous protocols for transport layer. TCP is, I'm going to summarize, okay? It's all mentioned here. I'm just summarizing for you. So please pay attention. It's always coming in the exams, asking you a question. What is the difference? Which one is reliable? So I'm gonna tell you the information. Inshallah, you guarantee some marks, okay? TCP is reliable protocol. TCP is slower than UDP because it's reliable. It depends on three-way handshake. So it waits for acknowledgements and make sure that the data is received. That's why it has overhead. Okay, so it's used for applications that the accuracy is important for them, like email. SMTP uses, SMTP is an application protocol, but it relies on TCP. Okay. IP telephony, UDP, because the speed is important. All right, you want speed, even if one character is not heard clear, at least it's okay, but at least you need to hear the sentence. All right. UDP only cares about sending. Overhead very low, faster. Okay, there is no handshake. It does not have a three-way handshake. Less overhead. All right. So we have explained these slides. This is the TCP header and the UDP header. You see the TCP header is much bigger. It has more overhead, has more information. Okay. So it has source port, destination port, sequence number, acknowledgement number, flags, window, header. But here in the UDP header, only this source, destination, length, and checksum. That's it. For error detection. And if there's some problems with the frame.
So send it again, right?
This is just to detect by application it will ask. The UDP it will not ask. UDP will not ask for retransmission. But this is used by other applications to find that, oh, there is a problem. The application will send, oh, okay, this is not correct, send or whatever, correct. So here we have this table here. These are on top, these are applications protocol. As I just told you, SMTP email will rely on TCP. But for instance, SNMP will rely on UDP because it needs speed. Then everything is going to IP. It will go to the internet layer. Okay? So these are all network protocols: OSPF, RSVP, IGMP, ICMP. These are network protocols. If they ask you, is this the network protocol? Yes. These are routing protocol. If you study advanced networking, of course, you will learn about OSPF, these protocols, ISIS.
Doctor, also in TCP we have the HTTPS, correct? It's included.
Yeah, you are where? Here. Ah, yes, this is application, HTTPS, yeah. Same, but it's secure. TCP IP applications, now we talk about each one. SMTP is Simple Mail Transfer Protocol, supports a basic electronic mail facility by providing a mechanism for transferring messages among separate hosts. This includes mailing lists, return receipts, and forwarding. This is all taken care by SMTP. Okay. FTP for file transfer protocol. If you want to transfer files between two computers, you use FTP. SSH, you know Telnet?
Yes.
SSH is a secure version of Telnet. You have used SSH before? Yeah, these are, especially if you are network major, then you will use this SSH. It's a secure way of accessing router, to remote access to a device, to a router, to a switch. HTTP is Hypertext Transfer Protocol. It connects systems to web servers. Its primary function is to establish connection with the server and to send HTML pages back to a user browser. And when you access internet, a website, and as our colleague said here, HTTPS will do this, but it will be secure connection with HTTPS. Then we have SNMP, Simple Network Management Protocol. So these are all examples of applications protocols. SNMP is for network management, for network monitoring and control protocol. And you want to know what is connected to your switch, what is connected to your router. This is done by this protocol. Routers. They are used to interconnect independent networks. These are the essential functions of the routers. Link networks, decide on the best routing path, which path your packet should go, A or B or A, B, C. And it provides these functions without modification of networking architecture of any of the attached networks. And your router does not require you to use specific equipments. The router will just forward the traffic, forward the packets to you. Okay? So router to work, it needs these things. They call it issues, but these are information related to the router. You need to use addressing scheme because the router depends on IP address to decide. Also needs to know what's the maximum packet size. Okay. So if there's a packet that's too big, it can divide it into smaller packets. It's called fragmentation. Segmenting in transport layer. Here we call it fragmentation. This one, maximum packet size. Then we have interfaces, the hardware and software interfaces to various network. Okay, differ. Yani each network has different interface. Okay. Reliability. Operations should not depend on an assumption of network reliability. You always try to have a redundant network. And if I have, okay, 2 routers, it's not 100% guaranteed that both routers will work. Try to put another router so that if this is down, they can go this way instead of going this way, okay? Or this way, then up. This is how your TCP IP work, okay? So here we said that it starts from up, down. So it will start at the application. You are using your application. The application will produce data. The data will go to the TCP layer. If you are using HTTP, the TCP will say, okay, you are using HTTP. It will assign for you a port. What is the common port for HTTP? 80. So you have a process, HTTP browser, and the port for you is 80. These two things together, they are called socket. Okay? So this is identified by TCP. Why we are doing this? So that when you receive back the information, it's going to your browser. It's not going to your email. Okay? And if someone walks out, he will come back again from the door, not from the window, right? The same thing. The information. No, we are not talking with this example, not about. Okay, we are talking about you are sending email, you are sending a request to access a website. It comes back to your browser. How is this controlled? By the transport layer. Okay. Then we have, after the transport layer, it will go to the network layer. The network layer will check. This is who's the source, who's the destination. The destination, let's say you are sending a packet to cisco.com. So the router will decide, oh, okay, this is to cisco.com. I know I have my routing table. I know in order to go to that server, you have to go to this path. So it will send it to the next hub. We call the next router is the next hub. From the next hub, it will go again to the next one, until it arrives at the destination.
It's called edge, I think, something edge.
There are different routers, different edge, or I mean, this is different subject.
In cloud computing, we have similar
Yeah,
thing.
that's different. But here we are talking about the routers. Like you are going from gate to gate. We are talking about the gateways, gate to gate. They call it hub. When you are going hub to hub to hub, or router to router to router. From the router, when it arrives at that network, the final destination network, then it will go from the router, it will go inside, it will go to the data link or data access, network access. And the network access will connect that, will send it to the designated computer in the network. Okay? So, in summary, you have to know that the internet access deals with IP address. The data link or the data access deals with physical address or MAC address. Okay. And then we have the physical address. The physical will connect to the medium. So I suggest that please you read this diagram. When it arrives, it's going the opposite way. When it arrives, it will go up again. Okay, to the data access and network access, and then to the network or internet layer, to the transport layer, and then back to the application.
Don't we receive it the whole piece together and then he starts from top to bottom? Or
Yeah, from application down to physical. Then and then the receiver will come from physical to the application. Down, up, down, and then down, up. Okay. We have something called virtual private network. We will do a lab on this, almost maybe in November or end of October. This consists of a set of computers that interconnect by means of relatively unsecure networks. So VPN, they use encryption and special protocols to provide security. You studied about VPN in your crypto course. I think you've done a lot. Yeah, this helps you a lot to provide security. Okay. All right. VPN relies on IP security to secure the communication across a LAN or private or public one and the internet. Examples of the use of IP security and VPN is secure branch office connectivity over the internet, secure remote access over the internet, enhancing electronic commerce security. All right, these are all examples of the use of IP security and VPN. Also, the IPsec, it will do encryption and authentication for the traffic, for the whole traffic over the IP connection. So all distributed applications, including remote, log-on, client server, email, file transfer, and web access can be secured. In the old days when the internet was made, it was difficult. If you have account, if you want to access your bank account and you just use the internet, it's not secure. So when the VPN was invented, it was very important thing, big thing, because then you can secure your connection to the bank, or if you are accessing any government to apply for something, all done through VPN. Or if you are an employee, you are traveling, you want to access your corporate network, you use VPN.
Doctor, what's the relationship between IP security and the VPN?
VPN relies on IP security for the security. Okay. So IPsec will provide these security services to the VPN. IPsec operates in network devices such as a router or firewall. So the IPsec device will encrypt and compress the traffic, and it will decrypt and decompress traffic coming from the WAN. These operations, by the way, it will not be felt by the LAN or the user. The user will just send the data. He doesn't know whether this is going through VPN or just normal cable or normal traffic. Secure transmission is also possible with individual users who dial into a WAN. Such user workstations must implement IPsec protocol to provide security. This is with the dial in into the WAN. That's another type of connection. Here we have a diagram. Here you have your internet traffic. Internet by itself is not secure. To secure it, you direct it to go in your VPN tunnel. The VPN tunnel will secure your traffic because the internet by nature is not secure and it's not guaranteed. It is best effort. Does anyone guarantee you if you send email that it will be received? There is no guarantee, right? Internet will do best effort. The IP protocol of the internet is best effort. It will try its best. But there are other methods to guarantee and make sure that your email is received or your data is secure by using different applications. So here we have networking devices with IPsec protocol suite that will secure the connection. The benefits of IPsec, again, we summarize it. Stronger security to routers and firewalls. It is resistant to bypass with a firewall. It is below transport layer, so it's transparent to application. It is transparent to end users. Transparent meaning that they don't feel the difference. It does not affect. Also, can provide security for individual users if needed. Okay. Let me make this clearer for you. Yani if you are accessing the college, once you log in, the way you use your application is the same, whether you are accessing while you are sitting here or from different country even. Once you are in, you are in. Okay? So the VPN will only secure your connection, will encrypt. Okay? But it does not affect your applications. So it's transparent. IPsec functions in summary. It provides three main facilities. Authentication only function, which is called authentication header, AH. A combined authentication encryption function called ESP, and a key exchange function. For VPN, authentication and encryption are generally desired because you want it to be secure. Okay? I think this is the summary, by the way, here of this chapter. Please go over the summary and let me know if you have a question. You have covered some of these in your crypto course, right? ESP,
Yes.
good. AH, yeah. Some of it. But we will do this in the lab, inshallah, in November.